This is for Year 12 Specialists. It comes out of MAV 2018 Exam 1, question number 5. Find an antiderivative. So, I don't have to have C because it's an antiderivative. Okay, I've got a quadratic divided by a quadratic. So, I can't set up a situation where the derivative of the bottom is at the top. Therefore, I'm going to do a polynomial division. So 4x squared minus 4x plus 3 goes into 2x squared plus 1. 4 goes into 2 1/2, equal 1/2, plus 2x minus 1/2, all on top of 4x squared minus 4x plus 3. Could I use partial fractions to do this bit? That is, could I break my denominator into two factors, therefore use partial fractions to work on the numerators? If I was to look at the discriminant of my denominator, I've got minus 4 squared minus 4 times 4 times 3, which is 16 minus 3 lots of 16. This is going to be negative, therefore there are no factors, therefore not partial fractions. Maybe if I complete the square, maybe if I find the derivative. So what is the derivative of the bottom? It's going to be 8x minus 4. I've got a 2x. So if I had 2x minus 1 at the top, I could find the derivative by multiplying it by 4. So I'd have to have 2x minus 1 plus 1/2. Okay, so what am I going to do so far? I've got three things happening. I've got a half. I'm going to have 2x minus 1 on top of 4x squared minus 4x plus 3 plus 1/2 on top of 4x squared minus 4x plus 3. I'd like to, on this third one, complete the square in the denominator and use an inverse tan rule. So I've got 4x squared minus 4x plus 3. Take out a common factor of 4, leaves me with x squared minus x plus 3 minus a half squared is plus 1/4. Minus 1/4 leaves me with 4 x minus a half squared minus 1/4 plus 1/2. Okay, so I've got 1/2 on top of 4 x minus 1 squared plus 1/2. So I'm going to bring the half out the front and the quarter, so I've got 1/8. 1 on top of x minus 1/2 squared plus 1/2. So I'm looking for a on top of x squared plus a squared. A is going to be 1 on root 2. So I'm going to have 1 on root 2, so therefore root 2 on 8, x minus 1/2 squared plus 1/2. So I've got 1/2 plus 2x minus 1 on top of 4x squared minus 4x plus 3 plus root 2 on 8, 1 on root 2 on top of x minus 1/2 squared plus 1/2. If I integrate that with respect to x, I need 8x, so I'm going to multiply that by 4, therefore I'm going to have 1/4. So that gives me x on 2 plus 1/4 log base e of 4x squared minus 4x plus 3 plus root 2 on 8 inverse tan of x minus 1/2 1 on root 2, which is equal to root 2/8 inverse tan of root 2 x minus a half. And that's going to be my answer.